Here is my Ferrari 296. And this is the hybrid battery out of it. And we think the reason why this car don't start is something to do with this in the hybrid battery.
The story of Mat Armstrong's Ferrari 296 GTB rebuild is one of the most complex and frustrating projects ever undertaken by a supercar enthusiast. It begins with a vehicle that was far from perfect, a crash-damaged Ferrari 296 GTB purchased with the intention of restoring it to its former glory. However, Matt didn't stop at a standard rebuild or simple repairs. He aimed for something much more ambitious. He fitted the car with a full Ferrari 296 Challenge Kit, which is a race-spec package designed to turn a road car into a track-ready machine. The Challenge Kit transforms almost every aspect of the car, from the body panels to the aerodynamic features and the cooling system. While this makes the car far more aggressive in appearance and performance, it also introduced a series of unique and highly complicated mechanical challenges. One of the first issues encountered was that Ferrari itself refused to service the car in its modified state. According to dealership policies, a car that has been altered beyond factory specifications cannot be worked on until it has been restored to a standard, approved configuration. This meant that Matt's team had to first ensure that the bodywork met Ferrari's exacting standards before any dealership or certified technician could even attempt to start the car. Yet, even after the body repairs were completed, the car refused to start, presenting a problem that would become the central focus of the entire project: the hybrid battery system. The Ferrari 296 GTB relies on its hybrid system not only for performance, but also simply to start the vehicle. When the car was originally crashed, the airbags deployed, which had a devastating effect on the hybrid battery, putting it into a state from which it could not recover on its own. The cost of a replacement Ferrari lithium-ion hybrid battery is staggering, exceeding £18,000, and even a new battery would not be a plug-and-play solution. The battery must be specifically coded to the car using Ferrari's proprietary diagnostic software, known internally as Leonardo. Without this software, and without authorization from Ferrari itself, the battery cannot be integrated into the car's system, leaving Matt in a nearly impossible position. This early stage of the rebuild already highlights the extreme challenges of working on a modern hybrid supercar. Unlike older vehicles, where mechanical knowledge alone could often solve a problem, the hybrid system places nearly every repair, modification, or restoration project firmly in the hands of the manufacturer. For Matt, this was not just an inconvenience. It was a formidable wall that required careful navigation, technical skill, and significant financial investment to overcome. The mechanical complications did not stop with the battery. The Ferrari 296 Challenge Kit, while transformative for performance, was not designed to be installed on a standard road car. The race version of the 296 GTB has an entirely different front-end layout, with radiators repositioned to accommodate the aerodynamic enhancements. On a stock 296 GTB, the space on the front bonnet is largely empty or used for minor storage, but on the Challenge Kit, that same space is occupied by a large water radiator essential for cooling the race-spec modifications. Installing this radiator into a road car required custom fabrication of mounting brackets, a task undertaken by a specialist fabricator named Bob. Bob spent hours constructing these brackets to securely house the water radiator and relocate the air conditioning condensers, which also had to be repositioned to fit the modified layout. Once the brackets were installed, the main water radiator could finally be mounted, followed by the AC condensers. However, this was easier said than done. The air conditioning lines on the 296 GTB are almost entirely rigid aluminum, which made rerouting them extremely challenging. A rubber hose conversion kit added some flexibility, but even that was insufficient. Several sections had to be cut, repositioned, and welded, creating entirely new paths to the AC lines while ensuring proper flow and system functionality. This meticulous fabrication process, while technically impressive, further delayed the car's readiness for its first startup attempt. Only after these critical structural and mechanical adjustments could the team attempt to turn on the vehicle and determine whether the hybrid battery, or any other component, was the source of the persistent problems. When attention finally turned to the hybrid battery, the evidence pointed strongly to it as the root cause of the car's failure to start. Disconnecting the battery management module, which serves as the brain of the high-voltage hybrid system, resulted in the temporary cessation of constantly flashing hazard lights and allowed the 12-volt battery to charge normally. Reconnecting the module caused the entire system to shut down, confirming that the hybrid battery was indeed the core issue. Replacing the battery was financially risky. At £18,000 for a new unit, there was no guarantee it would resolve the problem. Nevertheless, with all other avenues exhausted, it became the only logical next step. Installing the new battery involved removing numerous components, including the main high-voltage cables, cooling lines, ground wires, and sensors such as a tire pressure monitoring system and temperature sensors. A boomerang-shaped structural brace also needed removal to allow the battery to drop free. Once the new battery was installed and everything reconnected, the team hoped for a smooth resolution. However, the results were mixed. While the 12-volt battery could charge and some ignition functions returned, the car continued to display a thermal runaway warning and refused to crank. Diagnostic tools confirmed that the fault codes were tied to the battery temperature sensors, suggesting either an internal sensor issue or, more likely, that the new battery had never been properly coded to the specific Ferrari. The proprietary Leonardo software, required for coding and authorization, is not available for independent purchase without significant cost, and even with the tool, certain functions required direct approval from Ferrari. This meant that even after spending tens of thousands on the battery, Mat's team could not be certain the car would run without the manufacturer's cooperation. Even after the hybrid battery replacement, the Ferrari 296 GTB continued to resist a smooth resolution. One of the biggest obstacles was not mechanical in the traditional sense, but logistical and procedural. Ferrari, like many manufacturers of modern supercars, enforces strict rules regarding who can work on its vehicles and under what conditions. For Mat, this meant that despite months of painstaking work, the car could not be taken to a dealership until every component, every wire, and every piece of trim met Ferrari's exact standards. This is where the unique difficulties of the rebuild began to multiply. Many parts of the car, particularly the wiring plugs and connectors, had to be repaired or replaced because original components were either damaged in the crash or could not be sourced separately. The team often had to improvise using sealants, such as Tiger Seal and even electrical tape. While these fixes were mechanically sound enough to allow progress on the car, any Ferrari technician examining them would almost certainly flag them as non-standard, potentially requiring a full wiring loom replacement. A replacement loom is not a minor repair. It requires stripping the car back to a bare shell and reassembling it from scratch. The financial implications alone are staggering, potentially costing tens of thousands of pounds, and the time commitment will extend the project by weeks, if not months. Adding to complexity, the car's hybrid system creates an additional layer of restrictions. Unlike traditional combustion engines where a skilled mechanic can often diagnose and repair problems independently, hybrid systems are closely controlled by the manufacturer. When Mat's team attempted to diagnose the persistent issues after installing the new battery, it became clear that the system's internal sensors were still not communicating correctly with the vehicle's electronics. Fault codes repeatedly pointed to battery temperature sensors, and physical inspections of wiring continuity confirmed that all connections were intact. This left only one explanation. The battery had never been coded to the vehicle, and without Ferrari's proprietary diagnostic system, Leonardo, the team could not authorize the battery to function fully. Even purchasing the software independently comes with enormous hurdles, including costs that could exceed £30,000 and the requirement for Ferrari's direct authorization for certain functions. These restrictions mean that the manufacturer effectively holds the keys to restarting the car, creating a situation where no amount of skill, money, or ingenuity outside Ferrari's network can fully guarantee success. Beyond the technical challenges, the rebuild also required careful consideration of safety protocols. After the initial crash, the car's airbags had deployed, and the hybrid system had effectively locked itself out. Modern supercars are designed with integrated safety systems that prevent operation under potentially dangerous conditions, which is why the thermal runaway warning persisted even after new battery was installed. The warning indicates a serious risk in a high-voltage system and forces the vehicle into a protective mode that disables ignition. This is not a fault of Mat's team. It is an intentional design feature that prioritizes safety over convenience. Understanding and navigating these safety features required not only advanced technical knowledge, but also precise coordination with both internal and external resources, including specialized fabricators, diagnostic tools, and eventually potential Ferrari approval. Even the physical layout of the car complicated matters further. The 296 Challenge Kit, with its race-spec radiators and altered front-end layout, made what would normally be straightforward tasks much more difficult. Relocating the AC condensers, fabricating new brackets, and rerouting aluminum lines required a combination of mechanical ingenuity and creative problem-solving. Each modification, while necessary for the car to function with the Challenge Kit, increased the risk of later detection by a Ferrari technician. Any visible modification that deviated from factory specifications could trigger additional work or requests for full part replacements, adding both time and cost to an already expensive and complex rebuild. Through all these obstacles, one fact became clear. Rebuilding a modern hybrid supercar like the Ferrari 296 GTB outside of the official dealer network is an entirely different challenge compared to restoring older vehicles. It is no longer simply a question of mechanical skill or craftsmanship. It requires navigating proprietary software, manufacturer restrictions, and safety protocols that are purposefully designed to prevent independent repairs. Mat Armstrong's project illustrates this reality vividly. Every solution seemed to create new problems. Every step forward required careful planning, and every repair carried the potential to trigger unforeseen complications. Even the team's successes, such as partial ignition functionality and the temporary clearing of hazard lights, highlighted the delicate balance required to progress without provoking the system's protective mechanisms. One of the most striking aspects of Mat Armstrong's Ferrari 296 GTB rebuild is not only the technical complexity, but also the enormous financial stakes involved. Every stage of the project has come with a significant price tag, turning what might have been a restoration challenge into a major investment gamble. The hybrid battery alone cost £18,000, a sum that would be substantial for any car, even a supercar, and yet it was only a single component in a list of expensive repairs and modifications. This battery was essential because the hybrid system is the backbone of the 296 GTB's functionality. Without it, the car simply will not start. However, purchasing a new battery was not a guaranteed solution. Even after installation, the system continued to display warnings related to thermal runaway and battery temperature sensors, demonstrating that money alone could not solve the intricate engineering and software challenges inherent to modern supercars. Beyond the battery, other parts of the build have added further costs. The Challenge Kit modifications, which included a race-spec front end, new radiators, and relocated AC components, required custom fabrication by a specialist named Bob. His work involved designing and building brackets, rerouting air conditioning lines, welding aluminum sections, and ensuring the entire system was securely mounted. These are highly specialized services that command premium rates, and their necessity demonstrates how modifying a road car to race specifications is not only technically challenging, but financially demanding. The prospect of needing a full wiring loom replacement adds another layer of potential cost. Because many of the connectors and plugs have been field repaired with sealant and tape, a Ferrari technician reviewing the car would almost certainly flag them as non-standard, potentially requiring the replacement of the entire loom. A new loom for a car like the 296 GTB is no small expense. It involves stripping the car down to its bare shell, reinstalling every component, and meticulously reconnecting all wiring. The labor and parts for such a process could easily reach tens of thousands of pounds, rivaling the cost of the diagnostic tools themselves. Even the proprietary Leonardo software, needed to properly code the new hybrid battery, carries a staggering potential cost of £20,000 to £30,000, and some functions require direct authorization from Ferrari. This creates a unique situation where the financial investment is tied as much to manufacturer permissions as it is to parts and labor. Every stage of the rebuild requires careful consideration, not just of technical feasibility, but also of cost-effectiveness, forcing Matt and his team to make strategic choices about what steps to prioritize and when to seek manufacturer involvement. The rising costs also highlight a fundamental reality of modern supercar ownership and restoration. These vehicles are designed to remain tightly integrated with the manufacturer throughout their life cycle. Unlike older cars, where independent repair shops and skilled enthusiasts could address nearly any issue, modern hybrids place critical systems, particularly high-voltage batteries and software-controlled electronics, entirely under manufacturer control. This means that for anyone attempting a rebuild outside of Ferrari's official network, costs quickly escalate not just because of parts and labor, but because certain tasks are effectively impossible to complete without official intervention. Even a well-funded team like Mat Armstrong's cannot guarantee success without Ferrari's cooperation. Every modification, every replacement, and every software-dependent repair carries not only financial cost, but also the potential risk of introducing new issues or triggering system warnings that stall progress further. Despite these challenges, Mat Armstrong and his team have shown remarkable perseverance. Every obstacle, from battery failures to fabricated radiator brackets, from rigid AC lines to dealer restrictions, has required careful problem-solving and resourcefulness. They have managed to advance the project, even when the car seemed entirely uncooperative. For example, after replacing the hybrid battery, the ignition could at least turn on, and some hazard light issues were cleared, representing tangible progress despite the remaining barriers. The team has had to work meticulously, step by step, with constant attention to detail, knowing that even minor oversights could result in hours of rework or additional expense. This persistence underlines not only their technical skill, but also their commitment to completing a project that has challenged the boundaries of what is possible for independent supercar restoration. In many ways, this aspect of the rebuild reflects a larger trend in the world of modern performance cars. Supercars are becoming increasingly reliant on proprietary systems and software, meaning that the role of the independent enthusiast or workshop is more constrained than ever before. The Ferrari 296 GTB rebuild demonstrates that even with talent, resources, and determination, navigating these modern vehicles requires not just mechanical skill but patience, strategic decision-making, and the willingness to absorb substantial financial risk. For Mat Armstrong, every step of the way has been a test of both engineering acumen and fiscal endurance, showing that passion for performance cars today is inseparable from understanding the high-stakes ecosystem in which they exist. Despite months of painstaking work and significant investment, the Ferrari 296 GTB continued to present obstacles that only the manufacturer could address. Modern supercars like the 296 are designed with intricate proprietary systems that place essential functions under Ferrari's control. One of the most critical of these is the hybrid battery coating process. Even after installing a brand new 18,000 pounds lithium-ion battery, Mat Armstrong's team could not bring the car fully to life because the battery had never been coded to the specific vehicle. Ferrari's proprietary diagnostic system, internally known as Leonardo, is required to program the battery, authorize its functions, and integrate it safely with the car's electronics. Without it, the car remained in protective mode designed to prevent potential electrical or mechanical failure, including displaying persistent thermal runaway warnings. The system is intentionally restrictive. Even if the software is purchased independently, which could cost upwards of £30,000, certain critical functions can only be executed with Ferrari's direct approval. This essentially gives the manufacturer the final say in whether the car can operate, creating a significant barrier for anyone attempting an independent rebuild of a modern hybrid supercar. Adding to the complexity, taking the vehicle to a Ferrari dealership was not a simple solution. Ferrari confirmed that they would service the car, but only once it was fully complete. This requirement meant that every modification, every repair, and every piece of trim had to meet factory specifications before a technician would even open the bonnet. The team faced the challenge of preparing the car in a way that maintained the integrity of the modifications they had performed, while still satisfying Ferrari's strict standards. Many components, particularly field-repaired wiring plugs that could not be sourced as original parts, were sealed using Tiger Seal and electrical tape. Although these fixes allowed progress in the rebuild, they would almost certainly be flagged by a Ferrari technician, potentially leading to the need for a complete wiring loom replacement. Such a replacement would involve dismantling the car down to its bare shell, reconnecting every wire, and reassembling the interior and exterior components, an extremely costly and time-consuming process that could rival the price of the proprietary diagnostic tool itself. The combination of dealer restrictions and coding requirements illustrates a broader reality about modern supercars. They are not designed for independent repair. Traditional vehicles could often be restored by skilled mechanics using ingenuity, experience, and aftermarket parts. Modern hybrid supercars, however, place critical safety and operational systems behind software and proprietary hardware. High-voltage batteries, temperature sensors, and integrated electronic management systems are inaccessible without official manufacturer approval. In Mat's case, even with a new battery installed, ignition functions partially returned, and some hazard light issues were resolved, the car still refused to start. The remaining barrier was essentially a combination of software, authorization, and system security, elements entirely outside the team's independent control. This situation highlights the delicate balancing act required for a successful rebuild. On one hand, Matt and his team had invested considerable time, labor, and money to fabricate custom parts, reroute air conditioning lines, mount radiators, and ensure all mechanical systems were operational. On the other hand, they were constrained by Ferrari's proprietary systems and strict dealership requirements, meaning that progress could be halted by factors entirely beyond their technical skill or mechanical ingenuity. Even minor oversights in repair or deviation from factory specifications could trigger warnings or prevent the car from starting, requiring additional intervention from the manufacturer. In this sense, the rebuild is as much a logistical and strategic challenge as a mechanical one, requiring careful planning, precise execution, and continuous attention to detail. The coding challenge also illustrates a key difference between hybrid supercars and their purely combustion engine predecessors. Traditional engines allow for direct intervention. A faulty battery, sensor, or ignition system could often be replaced or bypassed by an independent mechanic. In the Ferrari 296 GTB, safety systems prevent the car from operating if any critical parameter is not verified and authorized through Ferrari's proprietary software. The vehicle's designers intended this to ensure reliability, safety, and performance, but it also creates a near-impenetrable barrier for independent rebuilders. Mat Armstrong's project vividly demonstrates the difficulty of working with such systems. Even with considerable expertise, financial resources, and careful fabrication, independent operators are fundamentally limited by access to proprietary technology. This makes completing the project a test not only of mechanical skill, but also of patience, perseverance, and strategic problem-solving. Beyond the technical challenges and financial stakes, one of the most remarkable aspects of Mat Armstrong's Ferrari 296 GTB rebuild is the level of perseverance required to push through repeated setbacks. Every step of the project has demanded not only engineering skill, but also patience, creativity, and resilience. The hybrid battery, for example, represented both a mechanical and psychological hurdle. At 18,000 pounds, it was a major gamble. There was no guarantee that replacing it would solve the problem. Yet leaving it in place guaranteed the car would remain immobile. When the new battery was installed, the ignition partially returned, the hazard lights were cleared, and the dashboard lit up as if to suggest progress. Still, the car refused to start fully, locked in protective transport mode that could only be disengaged with Ferrari's proprietary access codes. This combination of progress and immediate new obstacles required Matt and his team to adapt continuously, troubleshoot creatively, and maintain morale despite frequent frustration. The emotional element of this project cannot be understated. For anyone who has undertaken a large, intricate restoration, the cycle of hope and setback is exhausting. But in the case of a modern hybrid supercar, those cycles are magnified exponentially by the combination of technology, manufacturer restrictions, and costs. Throughout the rebuild, the team's problem-solving skills were constantly put to the test. They had to fabricate entirely new brackets for the radiators and air conditioning condensers, reroute rigid aluminum AC lines, and mock-up systems that were functional enough to allow testing without triggering warnings. Each fabricated solution had to balance functionality with compliance to Ferrari's expectations, since deviations from the factory layout could result in further delays or additional expenses. In this environment, creativity and precision are equally important. Even the simplest seeming task, such as installing a radiator or connecting cooling lines, carries risk because of the complex interactions between mechanical and electronic systems in the 296 GTB. Every modification has consequences that could ripple across multiple systems, meaning that mistakes are expensive and time-consuming to fix. Another critical emotional and strategic challenge is the uncertainty inherent in the project. Even after spending significant sums on parts, fabrication, and labor, there is no guarantee that the car will start or operate normally without Ferrari's direct involvement. The team has to weigh every step carefully, understanding that spending tens of thousands of pounds or hours of labor could still leave them with unresolved issues. This uncertainty adds a layer of mental strain to an already complex technical challenge. Yet Mat Armstrong has persisted. Each day of work, each adjustment, and each temporary success has